Now, there are a few activities today, once you've finished everything, that you can participate in. So there's a couple of games that you can do to practice with hexadecimal, and there's this. Now, this is in two different formats. So one, I have paper copies, if you want to do it physically. The other way is that you could actually do it digitally. So I've uploaded this to Managebox, which you can find below. So essentially, this is all of the different ones that I've printed out, right, just in one big giant file. There's like 8 of them, and they're binary, or they're hexadecimal, or they're a mix of both. So on the first two, this one and this one, it's binary. Now I didn't want to use ones and zeros because, I mean, I should have, but I thought it would have made it too obvious what the design was. So instead, you're looking for exclamation points that are right side up versus upside down. So if I go in here, those are the only 2 characters, right? I could have used ones and zeros, but it was really easy to tell what was going on, right? You could see it without even coloring it in. So here, like I've got, here's a correct exclamation point, and here's an upside down one, here's a correct one, right? So I can color these. So if I click on a cell, right? If I click on a cell, I might have to click twice, once to get to the table and once to get into the cell. Then I can go into Format, and over here, I can click Cell, and then I can do Fill, and then I can do Black, right? So kind of 1 and 0. Now once I've done this, I don't have to do that for every single one, right? I mean, I could, but it's a little tedious. Instead, I can, on my keyboard, do Command C, and I can just do Command V in each spot where I have these correct exclamation points, right? And eventually doing that, I should be able to hopefully start seeing whatever the design is. Now that method works for pretty much all of them, but they don't all have exclamation points. The first 2 have exclamation points. This one has hex values. So I've talked a little bit before about how we, use binary with everything, but it's a little complicated to try to remember, all those strings of zeros and ones. Instead, we use a base 16 because that's easier for us to remember. The computer still converts it to binary, but we use base 16. And when we're doing colors in design work, especially online, hexadecimal is very commonly used. So there's 2 different ways that this can be written for hexadecimal. There's this way using 3 characters. There's also the way of using 6. 3 characters and 6 characters are essentially the same. If I open up a new window for y'all, let's see, hexadecimal color picker, we can do something like that, right? And so here, as I move this around, you can see the hex value, right? Hex values typically have 6, but you can use 3. So color hex, there we go. This is the one I wanted. So up here, if we, let's open a new tab. Hexadecimal color picker, right? On here in Google, we had this little thing, right? So if I look at one of these, right? If I copy this and I paste it in, right? We see the color there. I can also press enter and it gives us more information, right? So the hex value, and these are RGB values, which this kind of gets into binary actually, sort of. You can convert these into binary. Anyways, I'll talk about that in a moment. Anyways, the hexadecimal numbers here, right? This is the code for this color. Now, I said you can also use a code of 3 instead. Essentially, a code of 3 converts to having 2 digits of each one of those. So if I were to convert this into only 3 values, so let's see, we'd do 3, probably 8, and B, because we're rounding up, right? So D is really close towards the end, right? 2 is close to the bottom, 3 is close to the bottom. So 3, 8, and B, that would be probably the closest version, 3, 8, B, right? And you can see it's close. If I press return, right, it's not exact, but it's close, right? And so what it did, you can see, is it doubled each one of those letters, or each one of those numbers, right, that I wrote in there. So 38B became 3388BB, and that's fine. That's how we can do it. Having the full thing is a little bit more proper, but sometimes you need 3 to save space, like when I'm trying to fit a whole bunch of them into a grid here. So this is like the other one. You can go in here and you can start to figure out basically what this is a picture of. So if we go back to here and we type in FFF, we get white. So these ones we could just leave alone. If you wanted to, you could maybe clear out, right, the cell. So that way that might be a little bit easier. Plus then you'll know you already did it. Now what is 0, 0, 0? So 0, 0, 0 is black. So then we could go in here just like before and we could choose black, and then we could copy and paste all the way across, right, for each time that we see black. So yeah, that's how you can do this one. And of course you've got other values in here, like what is 00F, what is FEB, what is, I'm sure there's some more in here somewhere, F00, right? So what are these different values? So you can drop them into a website like Color Hex and find out what they are and then start to make that. You've got another one that's the same way. And so this is another one but a different image. Here's another one but a different image. Here you can see some other colors, 5AF, whatever that is. 0A0. Here's one more. And now this gets a little interesting. So this is, we have 3 values with each one being 4 binary values. So what this basically converts to is each one of these is 1 hexadecimal value, right? So 0 through F in hexadecimal, that represents 16 values, right? 0 through 15 if we convert it to decimal. 4 place values in binary is the same amount. So this is, you know, up to 2 values, this is up to 4 values, up to 8 values, and up to 16 values, right? And now keep in mind, 0 is a value as well, right? So this right here represents 15, or F. So this essentially right here is FFF, right? Just like we saw in the previous one, right? Same thing, just different way to represent that value. So in here, you would have to convert first the binary into those hexadecimal values to find out what color it is. And I have created 2 of those. Now, this art does come from the internet. I didn't create the original images, but these grids are original. So I converted them from the original pixel art that I found online into these grids. So you're not going to be able to find these grids. You'll have to do it the hard way. All right, now the other thing that you can check out we have Flippy Bit and the attack of the hexadecimals from base 16. And if we click, this one's pretty hard actually, in my opinion. So it gives you a value here, and then you can try to figure out what value it is. Now down here, it does help you out a little bit. There we go. Right, and so you can kind of see, but I did not. It's hard. Let's try one more time. So I'm trying to get FA. So if it's FA, that's almost everything being marked. Everything is FF. But if I can start to, where do I go? There we go, FA. 5 is not very high up there. Right? Too much. Wait. It's, yeah. Well, you get the idea. It's hard. Maybe you'll be much better at than I am. I'm quite a bit better at this one, Hex Invaders. Here are your matching colors. So this is very similar to what we were just doing with the grids, right? So you have the first 2 values are red, the middle two values are green, and the last two values are blue. And here's a little bit more information of sort of how they mix, right? So you can see these two at maximum value are yellow, these two at maximum value are cyan, those two at maximum value are magenta. Blah, blah, blah. Right, here's an invader coming down. If you mess up your color, then it shows those, right? You didn't hit the right one. And there's also the clock that you can click on and try that out. All right, so the first two are R, the second two are G, and the last two are B. So that would be blue, right? So that means this one is the one that I need to hit. All right, R, G, B. So this is going to be the green one. And it does get harder. The start is easy, but it does get harder. So R, G, B. So notice there's two green ones, right? FF is the maximum value. That means it should be the brightest green one. RGB, right? So there's two. This is not super bright, so it should be the darker green one. Right? And so completed level 1, and it starts to get harder. Now we've got magenta in here, right? So maximum red, maximum blue, that makes magenta. So you're starting to see some of the hexadecimal values and how we actually can represent colors in them as well. Green and blue, that should be sort of a cyan color. It's not yellow, so I'm going to go with this one. Yeah, dark red. So you can try those out. This one, it gets, I don't know if I'd say easier. It does. You get a little better at it as you go on. The first like 2 times I tried, I couldn't hit any of them, and now like what I hit like 2 of them, right? So that's infinitely better. Like I'm still terribly bad at it, but it's improvement. So try it out. That might help you get the hang of hexadecimal and binary and some of those things a little bit more before we have our quiz next time.